Question 1. First of all, we've got to simplify m to the power 3, or m cubed, multiplied by m to the power 4. Well, in this case, we add the indexes here, or the indices, and that gives us m to the power 7. Secondly, we've got to simplify 5n times p cubed, all cubed. Well, that's the same as writing this. We times it by itself again, and then again. Now, if I just look at this one, that's the same as writing this. And I won't do it for every single one, but you've basically got that 3 times over under multiplication. So what you can do is you can do it in any order you want, but you start with the numbers in this case first. That's just the way the answers are written. So we'd have 125, because that's 5 times 5 times 5. Then we'd have n, another one under multiplication, so that will be n cubed. And then we've got p cubed times p cubed times p cubed, so we add the powers, or the indices, and that's 3, 6, 9. Lastly, we have to simplify this expression, and we've got 32 q to the power 9 r to the power 4, all divided by 4 q cubed r. So let's start with the numbers first. 4's into 32 is 8. Q to the power 9 divided by q to the power 3. You take away the powers here, so you'd have 9 minus 3 is 6. And then r to the power 4, that would be r to the power 1, and 4 minus 1, that's 3. Question 2. We have to find the lowest common multiple of 40 and 56. Well, the way I do this, I just write 2 columns here. I do the prime factor decomposition of 40, so all prime numbers here under multiplication. So that's 2 times 20, which is 2 times 10, which is 2 times 5. 56 is 2 times 28, and 28 is 2 times 14, and 14 is 2 times 7. And then what I do is I compare them, see how many common factors they have. So far we have 4 because it's under multiplication, 2 times 2 in each case, and I can squeeze another 2 out of here. And the way I like to say it is, 40 would love to get its hands on this factor, which it doesn't have, and 40 times 7 is 280. And 56 would like to get its hands on number 5 here, and 5 times 56 is also 280, but you basically choose the one that's the easiest to do. You've got a calculator in this case, so it doesn't really matter. The next question, it says, write down the highest common factor of a and b. So in this case, it's kind of like my method partly done for you. So you've got 2 cubed times 3 times 5, and then we've got 2 squared times 3 times 5 squared, and I can write these out under multiplication here, and then I've got 2 squared here, and then 5 squared. Now in this case I've got to see the highest common factor, so I've got to try and see how many factors they have at most that they share. So I can do 2 twice, that's 4. I can't do another 2 here, but I can do a 3, and I can do one of the 5s. And then you say to yourself, 2 times 2 is 4, times 3 is 12, times 5 is 60. And look, the same thing here, 4 times 3 is 12, times 5 is 60. So the highest common factor of a and b will be 60. Question 3. There's a straight line shown on the grid, and we have to find an equation for it. So I think the easiest thing to do here is to say that if I go along 1 unit on the x, and we're going up by 3 times the amount on the y, So the gradient will be 3, and it looks like the intercept is at -6. So if y equals mx plus c, then we're just going to have 3x minus 6. So that's one way of looking at it. Another way is you could find two coordinates that you know. So in this case we knew 2, 0. This one we knew as 0, -6. And then you could find the gradient, which is the difference in the y. So we'll start with -6, take away 0, over 0, take away 2. So that's the change in y over the change in x. You could have had 0 take away -6, but that's a bit harder because 0 take away a negative is add. So I'm going to do it that way round. And I would end up with -6 over -2, which again is 3. And some of you might know the formula, y minus y1 is mx minus x1. And all you do is choose one of your coordinates that you know. So this one, it's the easiest one. And you just substitute x for 2 and y for 0. Sorry, x1 for 2 and y1 for 0. And basically you'd end up with y equals 3x minus 6. So I think as you get beyond GCSE and A-level, you're using more of this kind of approach here, whereas just looking at this grid, the simple way just seems to be to do this. Question 4. Rhea buys a van for 8,500 plus VAT of 20%. So we can use the multiplier effect here, 8,500 times 1.2, which is 20% added on straight away as a decimal. And on the calculator, which I'll just do now, that's 8,500 times 1.2, and that's £10,200. Then she pays the rest of the cost in 12 equal payments. So we've got £531.25 times 12. So 531.25 times 12 is £6,375. And what you have to do is find the ratio of the deposit Rhea pays to the total of the 12 equal payments. So let's have a look at that. So in this case, if 10,200 was the total cost and the 12 payments were 6,375, that means the deposit was 3,825, because then she went on to pay the £531.25 12 times until it was all paid off. So we want to put down here 6,375, which is the 12 payments. We've got to have that in its lowest form. So this will divide by 25, and I guess I'll do that on a calculator as it's the calculator paper. So 3825 divided by 25, that's 153. 25s would go into this as well. So 6,375 divided by 25, that's 255. And then if you add the digits up in 153, you get 9, so 3 will go into it. So 3 will go into this, and I don't need a calculator to know that's 51. And then 3s will go into this as well, so that's 85. So 51 to 85, I know that 3 times 17 is 51, just because when you play darts, treble 17 is 51. If you don't know that, you can look for other factors that they share. And I know that 5 17s is 85 by looking at it. So I know that this is 3 times 17, and this is 5 times 17. So in this case, I can just cancel by 17, and I'd have a final answer of 3 to 5. which is the most simple form. You can probably do it as a unitary ratio as well, so one of them being 1 by dividing both sides by 3 in this case, and then you could probably get away with doing this as a decimal on your calculator as long as you put the recurring sign in, but this is my ideal answer here. Question 5, we have to complete the table of values for y equals x squared minus x minus 6. And I've noticed here that this can factorise. You may not notice that, it doesn't really matter. So 3 and 2, start with a minus and just add 2. So I know that when x is negative 2, we're going to have 0, and when x is 3, we're also going to have 0. But if you don't like that, you can just put on your calculator the values in here. Just be careful that when you square a negative, it's always positive, and when you're taking away a negative, that becomes positive as well. So we can fill these numbers in here. So we get 6, 0, negative 4, negative 6. That'll be negative 6 and negative 4. I'll do this one. Let me just show the question here. I'll do this one so we can see how that worked. So we had negative 1 squared minus negative 1, take away 6. Of course, using your calculator, just be careful to put brackets in. Some calculators need the brackets, a couple of them don't. So you've got 1 plus 1 minus 6, which is 2 minus 6, which is negative 4, and so on. So just be careful there. Once you've got those numbers, you can then start by plotting them. So let's have a look. So we have negative 3, 6. So that's there. Then we have negative 2, 0. And then negative 1, negative 4. And then 0, negative 6. 1, negative 6. 2, negative 4. And then 3, 0. The average of these solution points here, x equals 3 and x equals negative 2, the average of those is 3 and negative 2 is 1 halved. That happens to be the line of symmetry, so if you're into that kind of stuff at the higher level, you can see where your line of symmetry will be. And all you're going to do now is draw the graph, and so I'll just turn my thing round here so I can get this smooth. That's not good. I'll do it again. It's a good idea to hold your breath when you're drawing a line because you've got more control there, believe it or not. Don't hold it for too long though. And then again. And then you can draw these bits here. Make sure it hasn't got, that it's not flat. And then that will be good enough for the graph from negative 3 to 3. So the last part of the question says, use your graph to find estimates of the solutions to the equation x squared minus x minus 6, which is given in green, equal to minus 2. So it's like having y equals this and y equals this, and you're putting them equal to each other. So y equals negative 2. I should use a ruler, but you'll get the idea here. Okay, so that's y equals negative 2. And obviously you would use a ruler in the exam because we now have to try and read off these quite accurately. So we've got 2, halfway between 2 and 3 is 2.5. So it looks as though we've got 2.6 there as one of them. And here, I'd say negative 1.6. And that's just using our graph to find estimates. So in the exam you'll have some kind of limits there of accuracy. And the limits of accuracy for the mark scheme were along the lines of 2.5 to 2.7 for this one, and negative 1.5 to negative 1.7 for this one. So That's quite good, so we can move on. Question 6. A force of 70 newtons acts on an area of 20 centimetres squares, and it says pressure is a force over the area. So we're given, first of all, F equals 70 and A equals 20. So we can put that in. And we know even without a calculator that's going to be 3.5, and we'll call that P1. It then says the force is increased by 10 newtons and the area is increased by 10 centimetre squares. Okay, so the force will now be 80 newtons and the area will now be 30 centimetre squares. So we'll have 80 over 30, which is just 8/3. We'll just leave it as that for now. Now, Helen says the pressure decreases by less than 20%. Is Helen correct? Well, I think what I would do is I would use my calculator to do P1 minus P2, compare it to where I started, which was P1, and then just times by 100 to get a percentage. And if that's negative or positive, it doesn't matter because I'm just looking for the net change. So I'm going to put in the numbers here. So I'm going to do 3.5 minus 8/3, which is just 8 divided by 3. And that gives me 0.83 recurring over P1, which is 3.5. So divide that by 3.5 and I get 0.23809 and so on. So what does that mean? Well, it means that the net change from here to here as a percentage, because don't forget I've got to times it by 100, which I didn't do, would be 23.809 and so on percent. Now, is that a decrease by less than 20%? Well, no, it isn't, because it's more than 20%. It's 23.809 and so on. So what you can say is here, no, it's more than 20%. And you can say it's more than 20% decrease. I think it would help if I just decimalised that for you straight away. There we go, 2.6 recurring. So you can see that it's definitely gone down, and there's all the figures to back up your statements. So for question 7, I've drawn in the rays already from the centre 0, 1, which is here. So they correspond from here to each of the vertices. Obviously this one and this one are on the same line. And then all I've done is I've got to think scale factor 1/3, so 1/3 as much. So if this was 3, I'm looking for somewhere where the distance between this line here and this line here is 1. And I can see it just here. Now, also, I can see that if this was 1, 2, 3, 4, 5, 6, I want it 1/3 as much, so that would be 2, so that would be here. And then this one, again 1/3 as much, so between this line and this line, there it is, 1, and then the last one is here. So that would be my shape scale factor 1/3, and of course you'd use a ruler. Question 8. 60 people were asked if they prefer to go on holiday in Britain, Spain or Italy. And it's made up of males and females. So we can have a nice table here. And 38 of the people were male. 11 of the 32 people who said Britain were female. So 11 of the people that said Britain, of the 32 people that said Britain, so that means that column adds up to 32, so that means this one must be 21. Then 8 males said Italy. Well, now we've got 21 and 8, that's 29, which leaves 9 here. Then it says 12 people said Spain. So that means this one must be 3 because only 9 and 3 make 12. And we know also that there were 60 people that were asked. So this has got to add up to 60. So reading down here, this must be 22 because 38 and 22 make 60. And because this is 22 and I have 11 and 3 already, that's 14, and that would leave this one to be 8. So these are not too bad to work out if you do them slowly. So one of the females is chosen at random. What's the probability that this female said Spain? Well, 3 out of, not 60, be careful, it's 3 out of 22 because it's one of the females is chosen. And that would be your answer. Question 9. I don't think this is particularly easy, but Jean invests £12,000 in an account, paying compound interest for 2 years. In the first year, the rate of interest is X%. Now, normally when you do compound interest, if the percentage rate was, say, 20%, then the multiplier would be 1.2 or 1.20, because you'd be having the whole amount, which is timesing by 1, doesn't change it, and you'd be adding 20%. So when you had your amount, say A, you would have all of A and then 20% more added on. So in effect you'd be doing this. But in this case we don't know what the percentage is, so we can't just write 1.x, that wouldn't make any sense. So what we'd say is, if we wanted to have an interest rate of 20%, we'd have 1.20. Well, this is 1 plus 20 hundredths, if you think about it. Because on your calculator, if you do 20 hundredths, you'll get 0.2 or 0.20. Now, that means that you can just replace this with x. So what you'd have is, you'd have 12,000 times, and then put this in a bracket, 1 plus x over 100, and that would be equal to 12,336, which is the end of the first year. And we can rearrange this, and we can use our calculator to find the answer. So before I reach for the calculator, because I'm not very good with that, I like to do things by hand as much as possible. So we can get a common denominator there. We can divide this by 100 and this by 100, or cancel, and we'd have 120 times 100 plus x equals 12,336, which means 100 plus x would be, and now I will use the calculator or I'm bound to get complaints from people, so we'll have 12,336 divided by 120, that gives 102.8, so x will be 2.8, i.e. 2.8%. So what you can do now is, in the second year the rate of interest is x over 2%, so you can just say that for the second year you start with what you had at the end of the first year and just times it by, well, think x over 2 will be 1.4%, because it's percent here. So what would that be? That would be 1.014, wouldn't it? 1.14 would be 14%, don't forget, we want 1.4%. So we just do that on the calculator, so we'd have 12,336 times 1.014, and that would give us 12,500 and 8.704, but as it's in pounds I would just leave it as this, and I would say to 2 decimal places, to the nearest penny, so to speak, and that would be my answer. Question 10. The vector A and the vector B are shown on the grid. The first thing we've got to do is draw and label a vector minus 2a. Well, first of all, this is like a gradient, so it's kind of going along 1 and up 2. So we can do this anywhere. We can go along 1 and up 2, and we can draw another vector a, and it's parallel. If we wanted to have minus a, it's just going in the opposite direction. So minus 2a, it would be like going along not just 1, but along 2 and down 4. So we need to have it somewhere on the diagram so we can stay within the grid. So why don't we start here and go along 2 and down 4 and join these up, and then draw the arrow, and that will be negative 2a. We've now got to work out a plus 2b as a column vector. Well, a tells us to always go along 1 and up 2, and b tells us to go along 1 and down 3. So a plus 2b would be the same as writing a plus a scalar multiple, 2 in this case, of b, which is 1 plus 2 and then 2 minus 6, because it's just like multiplying these out and then doing the x and the y components separately. So we'd have 1 plus 2 is 3, and 2 minus 6 is negative 4, and that would be our answer. Now we can show this on the grid also, because if we went A and then 2b, well, 2b we can see here is 2, negative 6, so we go along 2 and down 6 to here, and I could join this up here. And then would have our resultant vector. So we'd have a plus 2b, and that would be equal to this one here. And we've already got our answer. So let's draw this on. And that should be the same as 3 minus 4. Well, let's see if it is. 1, 2, 3, and then down 4. So which way will the arrow go? Well, I'm sure you've worked it out. The arrow would be here. So that shows the flow of what would happen, and that's the diagram that you'd have to draw. But in this case, you could just do the number work like so. Question 11. F and g are functions such that f of x is 2 over x squared, and g of x is 4x cubed. First of all, we've got to find f of negative 5. So we replace x in this case with negative 5. Be really careful of the sign here. Anything squared is positive. So we would have 2/25. And that would be the answer for here. Find f of g of 1. Well, we start from the inside here. So in this case we start with g taking on 1, and g of 1 would be 4 times 1 cubed, which is just 4. And then we'd have f of this would be the same as f of 4 as the input. So if we put 4 in place of x, because don't forget f of x is always going to be 2 over x squared, then f of 4 would be 2 over 4 squared, which is 16, and we can cancel that down to 1/8. Question 12. The graph of y against x represent 4 different types of proportionality, and we've got to match them up. So this is where y is proportional to x, so that means y is equal to k times x for some value of k. And if x is 0, y is 0, so that kind of narrows it down to these potential ones here. But it's a linear relationship, isn't it? So it's going to be a straight line relationship, and the only one that's straight line is this one, so B. Now we can get rid of that. So now the second one is y is proportional to the square of x, so y would be equal to kx squared for some value of k. Now if x is 0, y is 0, so it still has these two possibilities here. But I think you can see as x would go up, so y would go up. Now this one doesn't match that, whereas this one does. Now you could say, you could argue actually this one does here. But if you think about the simple graph of y equals x squared, say when k is 1 here, you've probably all seen this graph before. Now this one doesn't look like that, does it? So it's definitely not this one. So this is the one here, so it's D. Let's look at this one next, because it's the nicer one I think than this one to look at right now. So y is proportional to 1 over x, so that means y would be equal to k over x for some value of k. Well, let's just say x is 0. Well, that'll be undefined. So can you see here, there's no definition here, it's an asymptote. So straight away, you can say that one is the graph that we need, so it's C. If you don't like that, then what you can say is choose k as 1, for example, and that means as x goes up, y goes down, and this does match. So by default, this would be A. Okay, so it's kind of by elimination. Now, I think that's all I need to explain on this one. I'm sure some of you have got better explanations than that, but I'm going to move on to the next question now. Question 13. A, B, C and D are points on the circumference of a circle, centre O. FDE is a tangent to the circle, and we've got to show that y minus x equals 90. Well, I won't write all the reasons out in length, but if we start off by saying that OB equals OD radii, then we can say that this angle is x also, because we have isosceles triangle. So I'm not going to write everything in detail. Here, this angle, so we could say angle BOD equals 180 minus x, because angles in triangle equal 180 degrees. So if you think about it, this angle here would have to be 180 at least, because if you think about it, if the angles in a triangle add up to 180, you've got to see the number 180 in there somewhere. So if we take x away from this and take x away from this again, then when we add the base angles of x plus x, then what happens? We're back to 180, which is the sum. So we can say that angle BOD OD equals 180 minus 2x then, because that's just minus x minus another x. Now if that's the case, if we look at the diagram in a bit more detail, then we should be able to see that this top angle here, angle BCD, well that should be what? Well, angle at centre is twice angle at the circumference. So angle BCD should be half of angle BOD, so it should be 90 minus x. And we can say angle at centre is twice angle at circumference. And so we've got this one here, which is 90 minus x. And then the last thing to note is that this angle plus this one, well, they're angles in a cyclic quadrilateral. All that means is there's a four-sided polygon, quadrilateral, which is enclosed and touching the circle at all times. So it has 1, 2, 3, 4 points on the circle. So we can say opposite angles of a cyclic quad add up to 180 degrees. And so because we have 90 minus x and y here, we can say 90 minus x and y must equal 180. And if we just rearrange from that, then that's the same as y minus x equals 90, because all I did was just change the order of the y's and the x's and took 90 from both sides. So that's my solution and a bit of an explanation as to how I got there. The next part says Dylan was asked to give some possible values of x and y. He said y could be 200 and x could be 110, because from here 200 minus 110 is 90. But it's not just y minus x out of context. The context is the actual shape. Now, if you think about it, if you looked at that triangle here, triangle BOD, then x is very important. So if x was 110, then you'd have two base angles, so you'd already have 220 degrees in that triangle. So x equals 110 is too big for triangle BOD, for example. Or you could say something like y equals 200. Well, as it is in a triangle, that is impossible. And you could say that it's in, and I'll just zoom in a little bit. If you look here, you can see that it's in triangle BAD, isn't it? There's y, it's in triangle BAD. So, and we'll just put that down there as a little aside, i.e. triangle BAD. So something along those lines would do. Question 14. So we can see a distance time graph here, and we've got to use the graph to estimate the speed of the car at time 5 seconds. So I've looked along at 5 and I've already drawn my tangent in with a ruler as neatly as I can. Of course there's going to be a bit of leeway here, but you know, as long as you get it just touching the curve, then you should be okay. And then I've looked for to estimate the speed, and don't forget speed in terms of units is distance per time. So it's distance over time, and I can do this by finding the gradient of that line. And the best way, I think, is to use as much of a line as you possibly can. Don't just zoom into a tiny little triangle like so, because you're going to be getting a lot more inaccuracy there. So I've gone from here to here, which gives me 5, and then I've just made the triangle this one here, which is what I've looked at. And then I've gone up 20, 40, 60. be careful, these aren't 2s, they're 4s, so it's 4, 8, 12, 16, 20 to the next one because it's 60 to 80. So this is going to be 70 here. And so the estimate of the speed is just going to be 70 over 5 meters per second, which I get as 14 meters per second. The mark scheme I've had a look at, it says you're okay between 11 and 19 meters per second. So that's quite a lot of give there. And just out of interest, that question was 3 marks. Sorry if I've missed that off on some of the questions, but I've remembered on this one. Question 15. For me, this is the hardest question on the paper. That's just how my mind works. I'm not brilliant at probability, I have to say. I misread the question a couple of times. So the first thing is it says a darts team's going to play a match on Saturday and on Sunday. The probability that the team will win on Saturday is 0.45. So I was okay with this here. And then it said if they win on Saturday, the probability that they win on Sunday is 0.67. And I originally put 0.33 here. Now that is correct, but then I went on to duplicate that here and here. But if they do not win on Saturday, then the probability they win on Sunday is 0.35. And then here, this is going to be 0.65, isn't it? So yeah, I made a silly mistake. That's not reading the question. So please don't just say you've done 100 of these questions so you can just do them real quick. Read carefully. I think it's put in bold there to make you read it. So we want to find the probability that the team will win exactly one of the 2 matches. So we're either going to end up here, having gone this route, a win followed by a loss. Or we could end up here by having lost first, then won. But that's going to be, we'll win exactly one of the 2 matches. Okay, so you've got to find those probabilities, and we do those on the calculator. So we do the first one is 0.45 multiplied by 0.33, and the next one is 0.55 multiplied by 0.35. So I'll do those now. So 0.45 times 0.33, that's 0.1485. And then 0.55 times 0.35, that's 0.1925. And then all we do is we just add these ones up. So let's see what we get. And I get 0.341. Question 16. On the grid, we've got to draw the graph of x squared plus y squared equals 12.25. Well, if you think about it, a circle at the centre is x squared plus y squared equals r squared, where the radius is r. Now, using your calculator, if you do the square root of 12.25, you'll get 3.5. I'll just check that on my calculator. So r is 3.5 and the centre is at 0. So we've got our centre here, and all we've got to do is go 3.5 in all directions. So that's 3. So 3.5, I'll do it in a different colour, would be here, 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 and here. And then you'd probably use a compass, I would say. I don't have one at hand, so I will just try and draw a circle as best I can. So I'll do the quarter arcs here and try and join them up. Okay, I'm sure you can do better than that. So that's my circle, and now we've got to find estimates for the solutions of the simultaneous equations, so we want to find values of x and y, so I would say coordinates, because we have to see where this line here, 2x plus y equals 1, meets that circle. So let's try and rearrange 2x plus y equals 1. So if we have 2x plus y equals 1, we can take 2x from both sides, and we can see here the gradient is -2 and the intercept is 1 on the y. So we know that we've got 1 on the y for an intercept, and we know if we go along 1, we've got to go down twice as much. So we can just plot some points. So along 1, down 2, along 1, down 2, along 1, down 2, and so on. And then I can try and put a line through those points. That one wasn't done very well there. And so let's have a look. So I'll move that a little bit. So that's the first part done, and we can just try and read off now where we think we are. So for this one, I've got 2 here and -3. So I think one of them I can label as A, which is 2, -3, and the other one this is probably not going to be as good, but we'll give it a go. It looks about -1.1 and as high as 3.1. So they would be my solution points here. And you can write it out: x equals 2 and y equals -3, and x equals -1.1 and y is 3.1, but it's pretty much, you could see that from the way you've written the coordinates. So that's the solution for that question. You get a bit of leeway, obviously. I think on the mark scheme I remembered it said the circle doesn't have to be drawn exactly. It can be drawn freehand as long as it looks like a circle. Question 17. The histogram shows information about the times taken by some students to finish a puzzle. We've got to fill out and complete the frequency table. Well, the frequency I always look at as the area of the bar in question. So the length of this part here is 5, and 5 times 0.8 is 4. So for the next one, we've just got 10 times 0.4. You can use your calculator if you want, but that's 4 again. So I'll just write it here, 10 times 0.4. For this interval here, it's 10 again. And we're timesing it by 0.6, so that's going to be 6. This interval is 5, and it's 1 high, so it's 5 times 1. I should write these in. And the last one is 20 by 0.2, which again you can see is 4 without a calculator, I'm sure. So you'll have 4, 6, 5, and 4 as the missing parts there. It then says, find an estimate for the lower quartile of the times taken to finish the puzzle. I don't know if you use the formula here, n plus 1/4 for the first quartile, the first quarter. If not, have a look at your revision notes. I'm sure that it's in there somewhere. And as we have 23 bits of information, 4, 8, and 6 is 14, and 5 is 19, and 4 is 23, then 23 plus 1 over 4 is just 24 over 4, which is 6. So we're looking at the 6th bit of information from our frequency diagram. And if we look carefully, cumulatively, we've gone 4 so far if we take the first interval, and we want to go to the 6th one, so we want to go halfway from here to make a total of 6 altogether. And halfway between 5 and 15, well, 5 and 15 is 20, halved is 10. So 10 minutes would be perfectly acceptable. You could have just done 23 over 4 and have got 5.75, and then you could have done a similar calculation and ended up with, I think it's 9.375, but I personally would use this one here. So do check that one out, okay, before you just take it on board. So question 18, ABC, D, E, F, G, H is a cuboid, and we're given that AB is 7.3. We're given that CH is 8.1. And we're given that angle BCA is 48. So that's the first thing we need to draw in here is the diagonal there. And it means that this angle here is 48 degrees. We've got to find the size of the angle between AH. So where's AH? Let's have a look. So AH is here. And the plane, that's the flat surface ABCD. So what we can say is that if we look at this triangle here, we know that this is a right angle because this length here is perpendicular to the plane ABCD, which is the flat base, okay? So it's perpendicular to that, so that's definitely a right angle. Now, if we want to find the size of the angle between AH and the plane, then if you think about it, that must be this angle here. That's the one in question that we want to find in the end, okay? So what's the first thing that we can do? Well, what I would do is, I know that in the red triangle AHC that I've got a right angle and I've got one of the lengths, which is 8.1. So I think I can find AC because if I look carefully, I've got another right angle here, another right angle triangle, and don't forget I've got this angle, haven't I, 48. So I can say in triangle ABC, which is on the base, which is on the plane ABCD, I can say in triangle ABC sine 48 equals, well, opposite, which is 7.3, over hypotenuse, and I'll just call that y, because it's opposite the right angle. So y is going to be 7.3 divided by sine 48. And I'll do that on my calculator. So I've got 7.3 divided by sine 48. And that gives me, I'm going to write everything down. I suggest you always do this. 8.23118926. And so if I have that length there, then in the other triangle, so I can do this now, in triangle, the red one, AHC, C, I'll draw that a bit closer together so you don't get confused. So triangle AHC. Well, what have we got? We've got this length here, which is y, and we've got this length here, which is 8.1, and we know that that's a right angle. So to get the angle in question, can't we just use tan? We can say tan of A, which is A is what we want, is equal to opposite, which is 8.1, over adjacent, which is what's in my calculator memory. And on mine it's called ANS, so all I have to do is do arctan of both sides, or inverse tan. So A is going to be tan to the minus 1 of 8.1 over ANS. You can just type in that number here if you want. So I'll do that now. So inverse tan of 8.1 divided by, and I'm going to use my ANS button, close brackets. And what I get is, and I'll just create a bit of space here, I get A is 39.508,49231, but it wants it to one decimal place, so I'm going to write 39.5 degrees and put 1 dp in there. Question 19. It says the shape S is 1/4 of a solid sphere, that's important, and the volume of S is 576 pi. So surely 4 of those would be the entire volume, which is 4/3 pi r cubed. And the reason I've done that is because I want to find the value of r first, because that's not given at all in the question and we're going to need it. So to enable us to find the surface area of S, we've got to use this formula, so we're going to need r. So I can see on both sides we can divide through by pi and we can divide through by 4. So all I've got to do is times both sides by this 3 here. So 3 times 576 equals r cubed. And on the calculator, 3 times 576, that's 1728 equals r cubed. If you know your cube numbers, you can just write 12. If you don't, just use your calculator. So r is 12 centimetres. So the surface area, well, I can see that if I add this part here to this part here, it will just make a circle, won't it, of radius r. So we know that the surface area of S is going to be pi times radius squared. So that's the area of one circle, because it's two like halves put together, plus 1/4 of what this surface area would have been, because it's only 1/4, don't forget. And I've missed out one thing, so just put this in properly. So it's 1/4 of 4 pi times 12 squared. So I know that these quarters will cancel here. So I know 12 squared is 144 pi, if you don't, use your calculator, plus another 144 pi. So that's 288 pi, but it wants the answer to 3 significant figures. So 288 times pi on my calculator is 904.7786842, and it wants it to 3 significant figures, so I'm going to say 905 centimetre squares, and then I'm going to put 3 significant figures in here. Question 20. Martin did this question, and that was to rationalise the denominator. So I'm just going to be having a go and see if I can do this. So I would times top and bottom by 2 minus root 3 to get this difference of 2 squares coming in. So 2 minus root 3. When I say difference of 2 squares, it's like having a plus b and then a minus b. And you should know that a plus b times a minus b is just a squared minus b squared. So that kind of gets rid of the root signs, because it's just going to be a nice number without a root sign. So what I'm going to be left with here is 14. I'm just trying to write down as much as I can here to follow what's going on here. So we've got 2 plus root 3, 2 minus root 3, so it's fine so far. Then it looks like he just multiplies the top out. And then he says 2 times 2 is 4. Then he does this one, 2 plus 2 root 3. And then this one, I'll do a different colour to just save confusion. So that will be minus 2 root 3. So all looking good. But then, unfortunately, he says that a plus times a minus is a plus. So that would be where the error is there. So you can write your own explanation, okay? So the next one, Sean did this question, and that is to rationalise the denominator. So I think you'd times top and bottom by root 12, which is fine. So that's okay. And then that would give, so we're looking at 5 times root 3 times root 4. So there's the next mistake, because we know root 12 times root 12 is 12, but only root 3 times root 4 is root 12. And I think what she's done there is got the root sign mixed up. It should be round the 3, because if it's round the 4, you just get 5 times root 3 times 2 over 12, which is 5 times 2 times root 3 over 12. So can you see there? There's the mistake. Question 21. Jackson is trying to find the density in grams per centimetre cube of a block of wood. The block of wood is in the shape of a cuboid, and all the dimensions are given, and it says the length is given as 13.2 centimetres to the nearest millimetre. And don't forget, a millimetre is a tenth of a centimetre. So when you're finding the tolerance, or the upper and lower bounds, you just cut the unit of tolerance in half. So in this case, if you just do 0.1 divided by 2 on your calculator, then you can add and take 0.05. So in this case, it could be as high as 13.25 and as low as 13.15. Just check that on your calculator. For the width, it's given as 16 centimetres. So again, just take, add or take 0.05. So be careful here, it'd be 16.05 and as low as 15.95. And then you've got the height given as 21.7. Same process. And then the mass is 1,970 grams to the nearest 5 grams. So cut this in half so you can plus or minus 2.5 grams to each. So you get as high as 1972.5 and as low as 1967.5. So that's the first part. By considering bounds, work out the density of the wood. So I wouldn't worry too much. Just find the upper bound of the density, find the lower bound of the density, and then we'll go from there. So if we look at the formula, density is mass over volume, and it kind of tells you because it's grams over centimetre cubes, and grams is mass and centimetre cubes is volume. So if we want the upper bound, we want the mass to be the highest and we want the volume to be the lowest, because that will give us the biggest answer. Okay, so just think the top of the fraction is like cakes and the bottom of the fraction is like people. So to get the most cake, you want the most cake to start with and the least amount of people. So the top number has to be the biggest, which is 1972.5. And the bottom has to be, and put a bracket in your calculator when you do it, don't forget. I'll just add these in quickly. So do that on your calculator and let's have a look. And we get 0.43. I'll put this here because it's not exactly equal. So let's just get that done neater. So 0.4343828506, and then if I do the lower bound, that's going to be the least mass, so 1967.5, and the most volume, so it's just all of these numbers here. And on the calculator, that would give us, let's have a look. That gives us 0.4253677,546. So now you've got to be careful. So think to yourself, to get the answer, and you've got to consider the bounds, a suitable degree of accuracy is where they both can be rounded to the same number. So if you go in a bit, say to here, can you see that this can round to 2 decimal places as 0.43? But then this can as well, because the 5 would round this up to a 3. So it would be 0.43 in both cases. So your final answer would be 0.43 grams per centimetre cube.